We are given that A union B is equal to A intersection B for two sets A and B. We have to prove from this that the set A is equal to the set B. So the way we'll do that is by using the definition of what it means for two sets to be equal. An arbitrary element drawn from A will be in B, and an arbitrary element drawn from B should be in A. So let's draw an arbitrary element from the set A. Let X belong to A. We have to show that X belongs to B. Now if X belongs to A, it will clearly belong to A union any other set. So it will clearly belong to A union B. X will clearly belong to A union B. Now since A union B is given to be equal to A intersection B, it follows from this equality that X also belongs to A intersection B. Now if X belongs to A intersection B, it follows that X belongs to A and X belongs to B. So it follows from this that X belongs to B. So an arbitrary element drawn from the set A belongs to B. So one part of the proof is over. We've shown that the set A is a subset of the set B. Now we have to take an arbitrary element from the set B and show that it belongs to A. So if X belongs to B, X will clearly belong to the union of B and A. And because A union B is given to be equal to A intersection B, X will belong to A intersection B. This means X belongs to both A and B. So X clearly belongs to A. Since an arbitrary element of the set B belongs to the set A, it follows from this that the set B is a subset of A. And because A is a subset of B and B is a subset of A must be equal to B. In fact, we can see from the information given that this implication is not just a one-way implication, it's a two-way implication. If the sets A and B are equal, A union B will be just A and A intersection B will also be just A. So if A is equal to B, it follows that A union B will be equal to A intersection B. So the implication is two-way, and so we can say that this is an if and only if condition. Although the problem just required us to prove a one-way implication. The problem just asked us to go from this information to prove that the sets A and B are equal. But we could have also gone the other way around.